Fun Science Time!
Whoa! Is this actually the Starship launch?
Precisely. Watch closely, Molly.
That's awesome! It's flying so high, way higher than any drone!
Drones fly with propellers in the sky. Rockets burn fuel to break gravity and fly into space.
So, rockets burn fuel just like cars? Is its huge body all for storing fuel?
Rocket fuel is totally different from car fuel. Its huge body has many special parts. Let's take a look inside.
All right.
Now we dive into rockets to explore their structure and how they work. Take the SpaceX Falcon 9. It's a high-precision rocket with 4 core systems. At the top is the payload fairing, acting as a shield for multi-million-dollar satellites.
Whoa! Check out that orange section. It looks like a massive fuel tank.
Exactly. That's the propellant system. To power the Falcon 9, that section holds super-chilled liquid oxygen and kerosene.
Wait, Kebo, liquid oxygen and kerosene?
Yepo, Lena. A car engine breathes oxygen from the atmosphere. But in the vacuum of space, there's no air. So a rocket has to carry liquid oxygen as its own breath to burn fuel and create thrust.
Then why use kerosene, not liquid hydrogen?
Kerosene, like RP1, is reliable, powerful, easy to handle, and best of all, it's super affordable.
And what about that blue ring in the middle? Does it act like a protective coat?
Nice analogy. This is the structural system. It's the rocket's skeleton and skin, holding all parts together and taking huge flight pressure. Finally, the propulsion system, or the engine cluster. Those are 9 Merlin engines firing together to generate over 7,600 kilonewtons of thrust.
7,600 kilonewtons? What does that even mean?
That's enough power to lift more than 500 fully loaded trucks straight up into the sky.
500 fully loaded trucks? What an amazing amount of thrust!
Impressive as it is, but Falcon 9 isn't the most powerful. Starship has almost 10 times more thrust. See? The white one on the left is Falcon 9 Block 5. It's 70 meters tall. The one on the right is Starship Block 3. It stands 150 meters high, more than twice the height of Falcon 9. Falcon 9 has 9 engines with 7,600 kilonewtons of thrust. Starship is equipped with 33 engines, delivering 72,000 kilonewtons of thrust, almost 10 times that of Falcon 9.
10 times the thrust? Let me do the math. That could lift almost 5,000 fully loaded trucks into the sky.
Nice math. Starship has such huge thrust mainly because it's built for Mars exploration. Falcon 9, on the other hand, is designed mostly for low Earth orbit mission.
Low Earth orbit? I remember from our drone and satellite episode, low orbit satellites are even 500 kilometers up.
Exactly. The International Space Station floats around 400 kilometers, and most low orbit satellites are around 500 kilometers high.
Getting satellites that high, and even all the way to Mars. The whole rocket launch process must be really complicated, right?
All right then, let's take a look at the main stages of a rocket launch.
Starship's 10th test flight?
Exactly.
Look at the screen! Those giant chopsticks are Starship's signature, right?
And the white fog! It looks like a giant dragon breathing. Is it breathing hard to charge up its power for space?
It sure does. It's letting out cold air to save up energy. The mist is just super cold oxygen. Still remember the liquid oxygen?
Yeah, rockets carry it to burn fuel and make thrust.
Preparations done, from cold standby to powerful blast. Phase 2, ignition and liftoff.
Whoa! Look at that wall of fire! Look at those engines blasting! The dragon is awake! It is actually ready for rising!
33 Raptor engines fire up together. That explains the huge flames. At 62 seconds, we hit max Q. This is the ultimate stress test for our structural system, the blue coat we talked about. Next stop, T plus 2 minutes and 42 seconds. Main engine cutoff and hot staging.
Wow! Do we just throw away such a huge rocket after staging? Isn't that such a waste?
Nope. Rockets can be reused now. Some are retrieved from the sea, while SpaceX catches theirs with those chopstick-style tower arms. At 8 minutes and 30 seconds, second engine cut off. Starship has successfully achieved orbit insertion. And now, with all engines silent, the ship officially enters the on-orbit coast phase.
Whoa! Look over there! Why did a cute little dinosaur just float out? And look at that water droplet! It's so perfectly round! Even our molecule family has never been that round before! Is it because it's already in space?
Exactly, Molly. Things get round in space, zero gravity. I created this little dinosaur just for you. In 2020, when SpaceX's Dragon carried its first astronauts, they brought a cartoon dinosaur to space, and it became super famous worldwide. In this coasting phase, Starship deploys satellites and releases space payloads.
So cool! That's SpaceX's famous Pez dispenser mode for space unloading. Satellites pop out one by one. It's absolutely amazing.
Correct, Lena. After releasing the satellites, Starship finishes its mission and gets ready to head back to Earth. It begins atmospheric re-entry at T plus 48 minutes and 20 seconds. Around T plus 1 hour, 5 minutes, 10 seconds, Starship makes a soft landing by ocean splashdown or chopstick catch recovery. All right, that's the whole rocket launch and recovery process. We just watched the hologram demo. Now let's review it with real footage.
Yay! I've been dying to rewatch the whole IFT-10 launch process. Especially videos with professional commentary. Hurry up, Kibbo!
All right, here we go. Now we enter the pre-launch phase. You can see the rocket is literally breathing. And now, ignition! All 33 Raptor engines burst into flames at once. Starship has liftoff! Main engines cut off. Hot staging takes place now. Here comes the super heavy booster heading for ocean splashdown. And now Starship starts deploying its satellites. Mission accomplished! Starship returns with a perfect ocean splashdown. Perfect conclusion. All right, that's SpaceX's 10th full launch journey.
And I heard the 12th flight is launching in just a few days, right?
Yes, perhaps tomorrow if the weather holds up.
Awesome! I'm definitely gonna watch the live stream. With all we've learned today, I can totally follow the whole launch process now.
Definitely. You can even explain the whole process to your family and friends.
I would love to.
Okay, that is all for today. Science is fun, right?
There are so many more fun topics to explore. Check out our playlist to find them.
Good luck to SpaceX's 12th launch.
Bye! See you next time.